They always told us Schrödinger's cat was just a thought experiment, a mental game, a paradox meant to reveal the absurdity of quantum mechanics when applied to the real world. The cat was never supposed to exist outside the mind, never supposed to cross from philosophy into the lab, and yet, one day scientists tried, not with a real cat, but with something that carried the same weight, the same essence. A living system pushed into the twilight zone between dead and alive, between two states that should never coexist. It wasn't a metaphor anymore. It was physics, raw, measurable, undeniable. This moment, often brushed aside in casual science talk, is one of the most haunting steps we've ever taken in quantum research, because it asks, what happens when the quantum blur, usually confined to particles and photons, infects life itself? Picture this. A system that should make sense to our classical intuition suddenly behaving as if it cannot decide what it is. The laboratory notes don't read like ordinary science. They read like someone opened the door to a new kind of reality, one where yes and no live together, one where even the definition of life flickers like a faulty light bulb. If Schrödinger's cat was a story, this was the rehearsal. And what they found forces us to ask questions we aren't ready for. What is real before we look? Can life itself exist in a superposition? And if so, what does that mean for us? To understand what really happened the day scientists decided to test Schrödinger's cat, we have to leave behind the fairy tale image of a cat in a box and step into the strange machinery of quantum physics. The original paradox was simple. A cat, sealed inside a box, its fate tied to a single quantum particle. If that particle decayed, a poison was released, and the cat died. If it didn't, the cat lived. In the quantum world, the particle existed in a superposition, both decayed and not decayed, until observed, which meant the cat, absurdly, was both alive and dead. Schrödinger designed this not as a celebration of quantum mechanics, but as a criticism of it. He was saying, this can't be right. It's madness. But here's where the story turns. Decades later, physicists began building systems where entire molecules, containing thousands of atoms, were forced into quantum superpositions. Then came viruses. Yes, viruses, biological entities walking the thin line between life and non-life, placed into quantum states. Researchers cooled them to near absolute zero, isolated them from the chaos of the environment, and watched as they behaved not like ordinary matter, but like particles in a quantum dance. This is not sci-fi. This is peer-reviewed science. In 2016, a team in Vienna proposed using living organisms, bacteria, even tardigrades, as candidates for superposition experiments. Their reasoning? If we can trap them, shield them, and cool them, we might push them into the same bizarre twilight zone Schrödinger imagined. And in 2017, researchers claimed to have entangled a tardigrade with a superconducting qubit, a microscopic animal, frozen in quantum limbo, briefly sharing its existence with a machine. Now pause and think. This is no longer philosophy. This is a collision between biology and quantum mechanics. The very boundary between life and physics starts to blur. If a virus or a microbe can exist in a superposition, does that mean it is both living and not living? If entangled with a qubit, does part of its identity stretch across realities? The unsettling part isn't just the experiment itself, it's what it whispers. If life can be placed into a superposition, even for a flicker of time, then Schrödinger's cat is no longer a metaphor. It is a roadmap. And the question no one wants to say aloud is this. If the cat can step into superposition in the lab, could we? Everything we know about reality tells us that things have to be one way or another. A glass of water is either on the table or it's not. A candle is either lit or extinguished. Life is either present or gone. Our entire common sense rests on this binary structure. But the experiments inspired by Schrödinger's cat are showing us a reality that refuses to obey this logic. When viruses, molecules, or even microscopic animals are forced into superposition, they don't choose a single state until we look. Instead, they live in a strange suspension, mathematically precise, physically real, yet completely alien to how we think the world should behave. The cat paradox was never supposed to be tested because it attacked our very definition of reality. How can something be alive and dead? The truth is, superposition does not fit into ordinary language. It's not that the system is in two states like flipping a coin and waiting for heads or tails. It's that reality itself stretches, overlapping like two images projected onto the same screen until the act of observation forces one to dominate. Take a moment to imagine this. A tardigrade, one of Earth's toughest life forms, frozen into stillness, connected to a quantum device. In the equations, it doesn't sit in one configuration. It's smeared across possibilities. To classical intuition, that's impossible. To quantum physics, it's inevitable. This breaks the illusion that common sense reflects how the universe works. Our brains evolved to throw spears, gather food, and survive predators, not to comprehend the rules of subatomic particles. We were built to live in the middle world, where objects appear solid, stable, and singular. But peel back that curtain, and you find a deeper layer where even existence itself behaves probabilistically. What unnerves scientists is not just that small particles obey these rules, it's that bigger and bigger systems seem willing to play along. Molecules, viruses, microanimals. Step by step, the border is shifting, and with each experiment, the absurd becomes more concrete. So here's the real crack in the wall. If superposition can stretch into the realm of biology, then our intuition about what it means to be alive collapses. Life is no longer a binary. Existence is no longer a certainty. And observation, the simple act of looking, becomes not just passive, but decisive. But if observation is decisive, then who or what is doing the observing? It's tempting to think these ideas are just abstract, a kind of quantum poetry. But the evidence trail is very real, and it's building step by step, experiment by experiment, like stones across a river. If we follow it carefully, we see how Schrödinger's cat stopped being just a metaphor and started becoming a testable reality. Step 1. Molecules in superposition. In the late 1990s and early 2000s, physicists managed to place large organic molecules, containing hundreds of atoms, into quantum states where they interfered with themselves like particles of light. This was shocking. Molecules are complex, messy, and vibrate with thermal energy. Yet, under the right conditions, they behaved like ghosts, occupying multiple paths at once. Step 2. Viruses and the edge of life. Around the mid-2010s, scientists began proposing and attempting experiments with viruses. Unlike molecules, viruses blur the line between living and non-living. Some researchers suggested that if viruses could be placed into a quantum superposition, we would literally have the closest possible thing to a living Schrödinger's cat. Though controversial, theoretical papers laid out how to trap and cool them into that liminal state. Step 3. The tardigrade entanglement. In 2021, a bold claim emerged. Researchers reported that they had entangled a tardigrade, yes, a tiny animal, with a superconducting qubit. The tardigrade was frozen, placed into a quantum circuit, and appeared to share its state with the machine. While some in the scientific community questioned whether this truly constituted quantum entanglement, the experiment marked a daring attempt to drag biology directly into quantum territory. Step 4. Quantum biology in action. Even beyond these headline-grabbing experiments, we now see signs that life itself might already exploit quantum weirdness. Photosynthesis, bird navigation, even our sense of smell. Each has experimental hints of quantum effects playing a role. This means that superposition and entanglement aren't just artificial lab tricks. They may already pulse through the very processes that sustain life on Earth. When you line these steps together, a picture emerges that is no longer dismissible. The boundary between the microscopic and the macroscopic is thinner than we ever imagined. Molecules, viruses, microscopic animals, all tested or proposed as participants in Schrödinger's paradox. And if life already leans on quantum rules, then maybe Schrödinger wasn't mocking quantum mechanics after all. Maybe he was warning us. One day, the cat would claw its way out of the box. But here's the question no experiment has dared to face yet. What happens if consciousness itself is placed in superposition? The moment you realize Schrödinger's cat has been nudged into reality, everything you thought was stable begins to wobble. It's not just about particles anymore. It's about life, identity, and the foundations of meaning itself. Because if a living system can exist in a superposition, what exactly does it mean to be alive? Life has always been defined in opposites: alive or dead, conscious or unconscious, present or absent. But quantum mechanics spits in the face of those clean categories. It says, until observed, you're both. Until interaction collapses the state, there is no singular truth. Philosophers have wrestled with this for decades. Some argue that the cat experiments don't mean the animal or the virus or the tardigrade is literally both alive and dead, but rather that our description of the system is incomplete. Others insist that superposition is not just mathematics. It is reality, raw and unfinished, until the spotlight of observation locks it down. The shockwave lies in what that implies for us. Are we comfortable with a universe where reality is not fixed but conditional? Where life itself may only exist as a probability cloud until someone or something interacts with it? Suddenly, our sense of stability feels like a thin illusion. Critics warn against exaggeration. They say no experiment has yet proven that a complex living creature can truly occupy two contradictory states. They argue that decoherence, the tendency for quantum effects to vanish in large systems, will always prevent a real cat scenario. But the counter-argument is even scarier. Decoherence doesn't eliminate quantum rules, it just hides them. And if we've already teased those rules out with viruses and tardigrades, who's to say where the boundary really ends? Imagine what this does to our view of consciousness. If life can flicker in superposition, maybe awareness itself is not a steady flame but a quantum shimmer, collapsing only when forced. That challenges not just science, but spirituality, ethics, and even responsibility. If alive and dead are not absolute categories, how do we draw moral lines? If identity itself can be smeared across possibilities, what does it mean to say, "This is me, here, now"? We used to laugh at Schrödinger's cat as a joke, a thought trap with no exit. But the laugh dies when you realize we've started to build the trap in real labs. And the moment the door swings open, the question waiting inside is one we're not ready to face. If life can exist in two states at once, are we already living in a superposition without knowing it? The real impact of Schrödinger's cat experiments doesn't sit in the past. It's in the future they hint at, the technologies, discoveries, and even revolutions they might ignite. Because the moment life and quantum mechanics touch, the possibilities open into something almost unrecognizable. Think about medicine. If viruses and cells can be manipulated in quantum superposition, we could one day design treatments that act before a disease fully chooses its destructive path. Imagine freezing a cancer cell in a liminal state, suspending it between survival and destruction, then nudging the probability toward healing. Quantum biology could be the ultimate scalpel, one that doesn't just cut but rewrites the script of life itself. Now think about computing. Today's quantum computers rely on qubits, tiny systems of electrons or photons balanced in superposition. But what if the qubits weren't artificial? What if living organisms themselves could be harnessed as quantum information carriers? It sounds impossible, but the tardigrade experiment was the faintest whisper of that future. Biology woven directly into the machinery of quantum computation. A computer that breathes, learns, and calculates in ways no silicon chip ever could. And then there's communication. Quantum entanglement already promises unbreakable encryption and faster-than-light correlations. But if living systems can be entangled, the idea of a network of biological entities linked across distance, perhaps even across time, starts to shimmer on the horizon. A nervous system spanning continents. A hive mind internet that doesn't just connect machines, but connects life itself. Of course, the darker applications come just as quickly. Military labs might dream of superposed organisms used as weapons, entities that exist in uncertain states until unleashed. Surveillance systems might not just observe what you do, but manipulate the very probabilities of your actions. Once life is treated as a quantum state, control becomes less about force and more about steering the conditions of reality itself. And beneath all of this sits the most haunting frontier, human consciousness. If viruses and tardigrades can enter superposition, then one day, with the right shielding and cooling, human brain processes could be tested the same way. Not all at once, but neuron by neuron, synapse by synapse. What happens when thought itself is placed in superposition? Could we hold multiple conscious states at once? Could a decision fork into parallel selves that remain linked? That's not just science fiction. It's the logical continuation of a road we've already started walking. And once we take that step, the boundary between observer and observed collapses forever. Because if consciousness enters the quantum box, who opens it? It's easy to hear about Schrödinger's cat becoming real and think it's just a distant experiment in some sterile lab. But here's the truth. It reaches straight into your life, into your choices, into how you see yourself. Because the cat isn't really about a box, or a particle, or a frozen micro-animal. It's about you, right now, sitting here, listening. Think about the decisions you make every day, the job you take, the message you send or don't send, the risks you embrace or avoid. In your mind, each choice feels solid, fixed, as though you've drawn a single line through time. But quantum mechanics whispers something different, that reality doesn't always pick one outcome right away, that possibilities can overlap, shimmer, coexist, and that the line between what is and what could be is thinner than you imagine. This isn't abstract. It's the way you carry uncertainty. How often have you felt suspended between two states, wanting to leap forward but also wanting to hold back? In our everyday language, we call that indecision. In quantum terms, it's a superposition of futures. You're not locked until you or something outside you forces the collapse. And here's where it gets intimate. The cat experiment shows us that observation isn't passive, it's active. It decides, which means the way you see yourself, the way others see you, the perspective you choose to adopt, it changes the state you end up in. If viruses, tardigrades, and photons can all live in this strange twilight of probability, maybe so can your identity, your goals, your very sense of being. That realization can be terrifying, but it can also be liberating, because it suggests you are not just the product of a fixed past. You are a spectrum of potential, waiting to be collapsed into form. And every interaction, every decision, every observer, including you, plays a role in shaping which version of you steps out of the box. This doesn't mean we live in a fantasy where anything is possible. Physics still sets boundaries. But it does mean that the idea of being stuck in one version of life is an illusion. The cat experiment teaches us that the universe itself is built on uncertainty, and within that uncertainty there is freedom. So the next time you feel trapped, torn, or unsure, remember, maybe that's not a weakness. Maybe it's the most quantum thing about you. You are Schrödinger's cat, and every moment you are choosing which self emerges. But what happens when the universe itself, not you, decides the collapse? So here we are, at the edge of the box. What began as a strange story, a cat neither alive nor dead, has slipped out of the pages of thought experiments and into real laboratories. Molecules, viruses, even tardigrades have been pulled into the quantum twilight. And with each step, the line between imagination and reality fades. The shocking part isn't just that the science worked, it's that the questions never went away. Instead, they grew sharper, more personal. What is life when it can be suspended between states? What is consciousness if it can shimmer across possibilities? And what does it mean for us, as humans, to realize that reality itself isn't as solid as it feels beneath our feet? Schrödinger thought his cat would expose the absurdity of quantum mechanics. Instead, the cat exposed us. It forced us to see that our common sense is a fragile lens, built for survival, but blind to the deeper machinery of existence. We laugh at the paradox, but deep down, we know it points at something true, something about possibility, about choice, about the mystery of being alive at all. And maybe that's why this experiment resonates so deeply, because it's not just about physics, it's about us, walking through a world where multiple futures are always hovering, waiting, balanced like a coin in the air. The lab may use photons and qubits, but the question it really asks is human. Which version of reality will collapse when it's your turn to open the box? So I'll leave you with this. Do you believe that Schrödinger's cat becoming real changes everything we thought we knew? Or is it still just science fiction dressed up as fact? Tell me below. Your view might change someone's mind.